Hi guys, in this video, I want to give you some ideas on uh, working with the Jordan normal form. Okay, so in general, we can write the Jordan we can write the Jordan block in like two different ways. So let's say we have an n by n Jordan block. Looks like this. Goes down like that, and then the last column is like that. Okay. So the ones, so the diagonal is all zeros, and just above is all ones. Sorry, let me adjust. Sorry about that. Right, so this is J, and we can write this in two. Well, I hope it's helpful. Two different ways. Right, we can organize it according to columns. If we do that, first column is the zero vector. The second column is the first standard basis vector. The third column is the second standard basis vector, and so on. The nth column is the n minus 1 standard basis vector. Okay. And you can think of it like you take the identity matrix, which has this. This is the identity matrix, and you just chop off the last column and put a first column as zeros. Okay, so you shift everything over. Okay, but we can also do the same thing, but like writing it as rows. So if we write the first row is like the transpose of E2. So I'll write it like E2 transpose. The second row is E3 transpose. The second to last row is En transpose. And the very last row is 0. So the zero vector transpose. Okay. Okay, and then this lets us like do something like figure out what is j times j. What is j squared? Well, it's just this is j and this is j, so we can write it as E2 transpose, E3 transpose, En transpose 0 plus or times this row. Okay. So if we forget that these are all vectors, this is an n by 1 matrix times a 1 by n. Okay. Um, Actually, this is a perfectly fine way to do it, but the way I meant to do it was the other way. So I meant to put this here. Yes. Of course, you can also do it the original way I wrote out, but to, to me, I like this way better. Okay, so these are both j. I've just written them in different ways. And now we just think to ourselves, so I have a 1 by n times an n by 1. How do I multiply them out? Well, I just, it's like a dot product or something. Okay, so I pretend that these are just 1 by n times an n by 1. And I multiply. I get 0 vector times E2 transpose plus E1 times E3 transpose. And then the second to last thing is plus En minus 2 En transpose plus En minus 1 0 transpose. Of course, the things involved in the zero vectors are just 0. Let's think about what is E1 times E3 transpose. Well, it is a vector or sorry, it is an n by n matrix with a 1 in the first row and third column. And E2, E4 transpose, has a 1 in the second row and fourth column. Right, so if you work it out, this tells us that J squared has all zeros except for ones. Has all ones, like 2 entries above the diagonal instead of just 1 entry. Okay. And similarly, J cubed has ones 3 entries above the diagonal, and so on. So let me try and write out J cubed nicely. So just looks like this. And 1's going like that. And then the last column is like that. Okay, and we can rewrite it again. We can rewrite it as like first column is 0, second column is 0, and then we have E1, E2, all the way down to En minus 2. Okay, that's J cubed. Okay, and this tells us, like, it kind of gives us an idea of like what J should do when we multiply by a matrix, right? So let A be, I'll write it, okay, I want to write out A in some way. Let's decide later how to write it out, but this is going to be an n by n matrix. Okay, and let's compute A times J. Oh, no, sorry, let's compute J times A first. Okay, so one way to do this is to take each row of J and multiply it to A. So we'll write J out as its rows. So the rows of J are like E2, E3, transpose, transpose, En transpose, and then 0, and then multiplied by A. So and the result of this multiplication, so if we think about this as an n by 1 times a 1 by 1, the result of multiplication is just E2 transpose A, E3 transpose A, then En transpose A, and then 0 as the last row. Okay. And what is E2 transpose times A? Well, if you just try it out, this is just the second row of A, this is the third row of A, this is the nth row of A, and this is 0. So multiplication, if we multiply J times A, it has the result of moving all the rows up 1, and then, so the first row kind of disappears, and then the last row, we added zeros. Okay, so let's rewrite this. So J times A has the effect that the rows of A are all shifted up by 1. Okay. Okay. And then let's compute what is A times J, the reverse direction. What is J times A? or sorry, what is A times J? We did JA, so now what is AJ? So I want to do the same kind of thing, except I want to write out the rows, or sorry, J into its columns. So the columns of J are 0, E1, E2, up to En minus 1. Okay, so now we're thinking of multiplying A, which is, we think of in block matrix terms, this is a 1 by 1 times a 1 by n. So how do we multiply? Well, we do A times 0. Second column is AE1. Third column is AE2. The nth column is AEn minus 1. And again, now A0 is just a 0 vector. AE1, that's the first column of A. So, how do I want to write the first column? I'll write it like that. Then the second column, then the n minus first column. So if we do AJ, that has the effect of moving all the columns to the right. And then like kind of the nth column falls off the edge and then we get a 0. Becomes the first column. Okay. Okay, so in the assignment you have to figure out, you have to solve this equation. Well, that just means you have to look for matrices A such that so if I rewrite, so A times J is this matrix. Like this, or sorry, no, I wrote these in the wrong order. A11, A21, AN1, and then A12, A22, AN2, and the last column is A1n minus 1, A2n minus 1, ANn minus 1, and that's A times J. And then you have to work that out. You have to compare it to J times A, which is, right, so the first row is the second row. So A21, A22, all the way up to A2n, and then A31, A32, to A3n. Oh yeah, and then we have second to last row is AN1, AN2 to ANN, and then the last row is all zeros. Okay, and once you have that, you can just compare things, right? So it tells you like A21 is 0, A31 is 0, AN1 is 0, 0 equals 0, but it also tells you that AN1 is 0, AN2 is 0, right? Stuff like that. What else does it tell you? It also tells you like lots of things, like tells you that A1 n minus 1 equals A2n, and all kinds of equations. So okay, for the assignment you just have to look at the 4x4 case. So I'll leave you to write out what it means for a 4x4 matrix to satisfy these two equations, and then like figure out what A should be. Okay, so I'm gonna make another video speaking about the Jordan normal form. So anyways, thanks for watching.